So in this video, we're going to talk about how to estimate the parameters of an ARCH process. And I'm going to generate a realization from ARCH data so that we know what we're dealing with and we know if we've done a good job. So let me come over here and so I'm going to generate a realization. I'm going to call it U1. I'm going to gen.arch.wge, and then I'm going to let it be a realization of length 1,000. I'm going to let alpha naught be 0.1, and then the alpha parameters be 0.5 and 0.4. So alpha 1 is 0.5 and alpha 2 is 0.4. And I'm going to let SN, just let SN be, let's say, 37. Okay. Now I'm going to estimate the parameters, and if you remember in reading the book, I talked about the fact that the TSWGE doesn't have a routine that estimates the parameters, but we can use the package T-series. So I'm going to do library okay. All right. Now T-series has a function called GARCH, and so I'm going to say u1.out. So what I generated was an ARCH2 model. So u1.out is GARCH u1 order equals C0 2. Okay, so what I've done there, again, recall, if you've read this part in the book already, that, you know, with ARMA models, we think of ARMA PQ, and for some reason, this GARCH package thinks of the models of the parameters of the GARCH model backwards to me, and they put the Q first and the P second. So P is 2 and Q is 0. And so again, I knew the order of the model, so that was helpful. So what I'm trying to do is see if I estimated the parameters of the model fairly well. So the results are found by taking a summary of u1.out. So if you recall, alpha naught was 0.1, alpha 1 was 0.5, and alpha 2 was 0.4. So you can see here that alpha naught is about 0.1, alpha 1 is about 0.5, and alpha 2 is about 0.4. So it did a really good job, and those parameter estimates are significant. The following Jacquet-Barra test to see whether the data look like normal data, and the box lung test checked the residuals to see if they look like white noise. Both of those seem to be doing a good job, and so that data set looks like it was probably pretty well modeled as an ARCH2 model. So let me just generate another one. So let me just say maybe 337, and let me estimate the parameters and do a summary. And again, I did a pretty good job. The point over here, the alpha naught is about 0.1, alpha 1 is a little over 0.5, and alpha 2 is a little over 0.44. So those did well, and the data nearly rejected sort of normality, but it didn't quite, and the box lung test seems okay. So that was sort of cheating because we were estimating the parameters of an ARCH2 model, knowing that it was an ARCH2 model. So let's just see what would happen if we said, okay, well, let's model this as an ARCH3 model. Okay, I'm messing up here, but let me try it again. Okay, so I'm not sure what this first error message was, but it doesn't seem to have bothered things. So I modeled this as an arch 3, and I can see that the first one is 0.008, that's close to 0.1. The second one is 0.7, that's a little higher than 0.5. The next one is 0.4, and then the alpha 3 parameter, which is non-existent, is infinitesimally small, the estimate is. The other parameters look fairly good, except the box lung test did a bad job of estimating. It doesn't think the residuals are white noise. So let me just do it again just to sort of test this stuff out. So let's generate another one. So let me, first of all, let it estimate it as the parameters of an arch 2, which is the right thing to do. And I see there, well, those aren't as good, but the alpha 1 and alpha 2 were fairly close together. This has them reversed in order, but that did a fairly good job of fitting the model, but not as well as before. And I'll just do one more just to sort of just get a gist of what's going on here. Okay, so these parameter estimates are quite good, and the normality and white noise tests seem to be okay. Now let me just one more time see what happens if I tell it it's an arch 3. And again, here I got about a 0.1, about a 0.5, and about